I want you to imagine something for a moment. Right now, as you're reading this, there's an object hurtling through our solar system that has scientists absolutely terrified to speak openly about what they're seeing. Not because the data is unclear, but because it's too clear. In just 47 days, on December 19th, 2025, we're going to find out if we're alone in the universe. And here's what's keeping astronomers up at night. The physics says one thing must happen, but if it doesn't, there's only one explanation left, and it's the one nobody in the scientific establishment wants to say out loud. Let me tell you about the calculation that changed everything. Picture this. You're an astrophysicist. You've spent your entire career studying the laws of physics, and suddenly you're handed data that makes absolutely no sense. That's exactly what happened when Avi Loeb ran the numbers on Atlas following the confirmation of its non-gravitational acceleration. What he discovered wasn't just unusual, it was physically impossible for any natural object. According to the fundamental laws of conservation of momentum, laws as solid as gravity itself, Atlas should have lost at least 1/16 of its entire mass during its close passage to our star. We're not talking about a little bit of dust here. We're talking about billions of tons of material ejected into space in just 1 month. That's the equivalent of Mount Everest being completely vaporized in 30 days. But here's where it gets truly disturbing. When you lose billions of tons of material in space, you don't just lose it quietly. It creates a massive, visible gas cloud, something that should be lighting up every telescope on Earth like a cosmic beacon. So where is it? We're looking at this object with some of the most sophisticated instruments humanity has ever built, and we're not seeing what should be there. This isn't a small discrepancy. This is the difference between theory and observation, so vast that it's forcing scientists to confront a possibility that most of them desperately want to avoid. The breakthrough that started this chain of events came from the Atacama Large Millimeter Array, one of Earth's most powerful radio telescope networks, positioned high in the Chilean desert where the air is so thin and dry that it can detect signals most other instruments would miss completely. On October 29, 2025, ALMA detected something that sent shockwaves through the astronomical community. Atlas was 4 arc-seconds away in right ascension from where it should have been if its trajectory were dictated purely by gravity. Now, 4 arc-seconds might sound tiny, meaningless even, like measuring the width of a hair from across a football field. But in astronomical terms, when you're tracking an object millions of kilometers away, 4 arc-seconds represents a massive deviation. It's not a measurement error. It's not instrument drift. It's real movement that can only be explained by forces beyond gravity acting on this object. The moment Avi Loeb learned of these results, he immediately began applying the laws of momentum conservation to calculate what this acceleration would mean if Atlas were a natural comet. The physics here is actually straightforward, the kind of calculations that undergraduate students learn. For Atlas to accelerate this much through normal cometary gas ejection, the nucleus would need to lose at least 1/16 of its total mass. When you run the numbers, the total evaporation time comes out to less than 6 months. Since it took approximately 1 month for Atlas to cross the perihelion distance scale of 203 million kilometers, The object must have lost at least 1/16 of its mass during that single month. These aren't speculative numbers. This is basic physics, the same physics that puts satellites in orbit and predicts planetary motions with perfect accuracy. Now we arrive at what scientists are quietly calling the missing mass problem, and this is where the story transforms from unusual to potentially civilization-changing. Previous measurements by the James Webb Space Telescope showed a mass loss rate of just 150 kilograms per second, which produced absolutely no detectable non-gravitational acceleration in the 5 months prior to October 2025. This observation led Loeb to conclude that Atlas's mass must be at least 33 billion tons. Think about that number for a moment. 33 billion tons. If this object lost 1/16 of that mass, we're talking about a dense cloud carrying at least 5.5 billion tons of material. That's not something you can miss. That's not something that hides in the darkness of space. We should be detecting a massive visible gas cloud around Atlas right now, something so obvious that amateur astronomers with backyard telescopes could spot it. The observation window coming up represents the best opportunity in human history to study this mysterious object. On December 19, 2025, Atlas will come closest to Earth at a separation of 269 million kilometers. That might sound far, but in astronomical terms, it's practically next door. Between November 27, 2025 and January 27, 2026, Atlas will be monitored by the International Asteroid Warning Network campaign, a coordinated effort involving hundreds of ground-based telescopes spanning the globe, along with the Hubble Space Telescope and the James Webb Space Telescope, the two most powerful space-based observatories humanity has ever built. Every major observatory on the planet will be pointed directly at this object. If there's gas to be found, we'll find it. And here's what makes this moment so critical. If this extensive observation campaign fails to reveal a massive gas cloud around Atlas, then cometary evaporation simply cannot constitute a natural explanation for its non-gravitational acceleration. As Loeb states with careful precision, if we do not observe a massive gas cloud around Atlas in December, then the non-gravitational acceleration reported near perihelion can be regarded as a technological signature of a propulsion system. Read that again. A technological signature, not a hypothesis, not speculation, a signature, observable evidence of engineered propulsion operating in our solar system right now. This scenario brings an eerie sense of déjà vu for anyone who followed the story of our first interstellar visitor. The object called Oumuamua exhibited non-gravitational acceleration without showing any signs of gas or dust around it, even after deep observations by the Spitzer Space Telescope specifically looking for such emissions. This led comet experts to define Oumuamua as a dark comet, essentially a comet that shows no visible tail. But as Loeb pointedly observes, given that a tail is the defining signature of a comet, the very notion of a dark comet is an oxymoron, a contradiction in terms. It's like calling something a dark light or a dry ocean. A spacecraft with a propulsion system could show non-gravitational acceleration without any cometary evaporation whatsoever. It could be classified by comet experts as a dark comet in the same way that a cave dweller would classify a cell phone as a rare stone, trying to fit something technological into a framework designed only to understand natural phenomena. The stakes of this observation campaign have attracted significant attention from science communicators who are making strong, definitive statements about Atlas being completely natural. Nothing to see here, just another space rock. However, Avi Loeb points out a crucial distinction that goes to the heart of how science actually works. Scientific truth is not decided by popularity contests, social media influence, or who can speak with the most confidence. It's decided by careful attention to data, especially when that data is anomalous, when it doesn't fit our comfortable models of reality. While communicators make sweeping statements backed by authority and institutional prestige, Loeb has written 11 scientific papers in recent months specifically about Atlas, systematically documenting and analyzing its unprecedented anomalies. In peer-reviewed literature where claims can be checked and challenged by other experts. The challenge that remains unanswered is this. Anyone claiming Atlas is definitively natural must explain all 9 documented anomalies, not just 1 or 2, but every single one. Cherry-picking which anomalies to address while ignoring others isn't science, it's wishful thinking. First, consider the impossible trajectory. Atlas arrived on a path perfectly aligned within 5 degrees of the ecliptic plane, the same plane where all planets in our solar system orbit. For an object supposedly coming from interstellar space, having wandered through the galaxy for millions or billions of years, this precision is statistically almost impossible. The galaxy is 3-dimensional. Objects can come from any angle, any direction. The odds of randomly arriving aligned with our solar system's plane is like shooting an arrow from another continent and hitting exactly the center of a target the size of a coin. Second, there's the physics-defying jet behavior. Comets normally eject material in the direction opposite to the sun because solar heating causes the sun-facing side to evaporate, and that gas pushes the comet like a rocket engine firing backward. This is basic action-reaction physics, but Atlas does the exact opposite. Its jet points directly toward our star, completely violating everything we understand about cometary behavior. It's like observing water flow upward in a waterfall or watching heat flow from cold to hot. It doesn't just seem wrong, it violates fundamental physical principles. Third, the size and speed contradiction presents a mathematical impossibility. Atlas's brightness tells us how much light it reflects, which indicates a relatively small object. But its velocity, the speed at which it moves through space, indicates something with far more mass. This fundamental contradiction challenges our basic laws of orbital physics. It's like watching a small car move with the inertia of a fully loaded freight train. The numbers don't reconcile. Fourth, there's the perfect timing that strains coincidence beyond breaking. Atlas arrived at the exact moment for close encounters with multiple planets in sequence: Earth, Venus, and Mercury. It's threading a gravitational needle with precision that would require extraordinary luck for a natural object that's been wandering randomly through space for eons. Think about the odds of this. The solar system is mostly empty space. Planets occupy tiny fractions of their orbital paths at any given moment. To arrive at just the right time to encounter multiple planets in sequence suggests either impossible luck or intentional planning. Fifth, spectral analyses reveal an industrial metal composition. When you analyze the light reflecting off Atlas, the signature doesn't match natural cometary materials, which should be ice, dust, and simple organic compounds. Instead, it resembles industrial alloys, processed metals of the kind you might find in manufactured objects. It's like finding stainless steel in what should be a dirty snowball from the outer reaches of space. Sixth, Atlas is the driest object ever observed in the solar system, and this completely challenges the basic definition of what a comet is. Comets are supposed to be dirty snowballs, mixtures of ice and rock. When they approach the sun, the ice sublimates, creating the characteristic tail. But Atlas shows virtually no water content whatsoever, even when heated to temperatures where any ice should be rapidly vaporizing. A comet without water is like finding a fish without fins, a fundamental contradiction of category. Seventh, the impossible polarization signature adds another layer of mystery. When light reflects off a surface, it becomes polarized in patterns that tell us about the material's properties. Light reflected by Atlas shows polarization patterns that don't match any known natural material in our solar system or any meteorite ever studied. It's as if the object's surface has artificial optical properties, engineered characteristics that simply don't exist in nature as we know it. Eighth, there's the wow signal connection, a coincidence so specific it's deeply unsettling. Atlas's direction of origin aligns suspiciously with the location of the famous wow signal, the strongest radio signal ever detected from space that many scientists believe could have an extraterrestrial origin. In 1977, a radio telescope detected a signal so powerful and unusual that the astronomer monitoring the data literally wrote, "Wow," in the margins. That signal came from a specific direction in space. Decades later, an object appears traveling from approximately the same direction, exhibiting impossible characteristics. The statistical odds of this directional coincidence are disturbing. Ninth, the impossible brightness behavior defies thermodynamics. As Atlas approaches the sun, it's getting brighter and bluer in color. Natural objects should behave oppositely. As they approach a heat source, they should heat up and shift toward red in the spectrum. It's like watching an object get colder while moving closer to a fire. This violates basic thermal physics. These 9 anomalies don't exist in isolation. They compound. Each one individually strains natural explanations. Together, they create a picture that becomes increasingly difficult to reconcile with any conventional understanding of comets, asteroids, or any natural solar system object. We are now approaching the most critical observation period in the history of interstellar object studies. The December 2025 observations will either detect a massive gas cloud, supporting the natural comet hypothesis despite all the other impossible characteristics, or they will fail to detect the expected cloud, providing what could be considered the first confirmed technological signature of an interstellar object. There's no middle ground here. The physics is binary. Either the gas is there or it isn't. If Atlas shows non-gravitational acceleration without the accompanying massive gas cloud that conservation of momentum absolutely requires, we would be looking at the first confirmed evidence of extraterrestrial technology operating within our solar system. This wouldn't be ancient evidence carved in stone. This wouldn't be distant radio signals requiring interpretation. This would be active technology demonstrating controlled propulsion under direct observation by humanity's most advanced instruments, watched in real time by thousands of professional astronomers across the globe. The coming weeks represent a genuinely unique moment in human history. We're not just studying an unusual object that doesn't quite fit our models. We're potentially witnessing the first real-time observation of extraterrestrial technology in operation. The physics is absolutely clear. Massive acceleration requires massive mass loss if you're using natural propulsion methods. If we don't see the 5.5 billion tons of gas that should accompany such mass loss, we're left with only one explanation that fits all the data. And that explanation changes everything about humanity's place in the cosmos. As we approach December 19th, when Atlas reaches its closest point to Earth, hundreds of telescopes across 6 continents will be searching for those missing billions of tons of gas. If that gas isn't there, if the observations come back negative, we'll know with scientific certainty that we're not looking at a comet. We'll be looking at something far more extraordinary, something that shouldn't exist according to our current understanding of what's naturally possible. We'll be looking at a piece of technology from another world, demonstrating propulsion capabilities that challenge everything we thought we knew about physics, engineering, and our solitary existence in an apparently empty universe. The countdown has begun. In just 47 days, we'll have our answer. Either we'll confirm Atlas as the strangest natural object ever observed, requiring us to completely rewrite our understanding of cometary physics, or we'll confirm something far more profound. We'll confirm that we're not alone, that we're being visited, and that right now, at this very moment, there's an engineered object from another civilization operating in our cosmic neighborhood. Stay tuned, because we're about to witness either the most unusual comet in all of cosmic history or humanity's first confirmed encounter with technology from the stars.